now that we have reviewed direct variation and inverse variation, we can now start to combine different types of variation. And so you can see from the concept box that we have multiple types of combined variation. Now, the first vocabulary word that you need to become familiar with is joint variation, and this basically tells us when a quantity varies directly with two or more quantities. And you tend to see this a lot in geometry when we start to have multiple variables in a problem, such as in our volume problems. And so if you see joint variation, we're referring to a type of direct variation, and of course if we say inverse, then we're looking to create something with a fractional form or denominator. So you definitely want to take the key concept summary box there and review that very carefully. Now, the easiest way to kind of learn these is trial by fire. So let's just jump in and do sample problem number 5. Take a look at the solution, and then you can move on to sample problem number 6 and see how you do there. So go ahead and work on sample problem 5. Okay, so we start by giving us a cost of constructing a 9 by 12 foot patio, and it tells us that the cost varies jointly with the length and the width. And so we were given the length and the width, we were given a cost, so the cost varies directly or jointly with length and width, so we have our constant of variation there. And now I just basically take the information that's given and plug it in. If you're ever unsure of where to start, the simplest thing to do is just write your variation equation that you're going to use and see where everything fits. And you can see here that we have a k value. We don't know what our constant of variation is. So we'll just go ahead and work this out and solve for k. So k equals 6.8. Now, how are we going to use that? The question basically asks, what does an 18 by 14 foot patio cost? And so we're looking for cost here. And now that we have a k value, we can use that to help us find the total cost of an 18 by 14 foot patio. So in this case, we have $761.60. And so that gives us our final answer. So you can see here a multi-step problem where we're required to solve for k first so that we can use it to find the ultimate cost of a larger patio. Alright, very good. So hopefully, if you haven't yet, go ahead and try sample problem number 6 and then come back and take a look at that. Alright, so we have a little bit more going on here. We have a direct variation and we have a inverse variation, and so we need to apply some values or some variables to each of these parts. So it says the number of bags of grass seed N varies directly with the area. So we know that N varies directly with the area, so we have Ka. So if that were all we had was a direct variation, we'd be done. But it also is inversely related to the weight of a bag of seed. And so our inverse relationship, if you were to, so to speak, cover up the A value, you now have K over W. And so you have the direct variation mixed in with the inverse variation. And so again, we can take the information that was given to us and plug it in and then just solve for whatever the missing part is. And so if we look at this, it says it takes two 3-pound bags. Alright, and then of seed to cover an area of 3,600 square feet. So we have 2 bags of grass seed. We don't know what our constant of variation is. We're looking for a 3,600 area of a 3-pound bag, the weight of a 3-pound bag. So there we go. And then we can simply solve for K. K is going to equal basically 1 over 600. If you plug that in and you got a decimal, that's perfectly acceptable, and you can go from there. Now, let me show you how we're going to use it. We want to know how many 3-pound bags, and this is kind of convenient because we're using the same weight here. How many 3-pound bags do we need to cover a 9,000 square foot area. Now, I'm going to go ahead and replace the K in our original equation. So that's going to be 1 over 600. And so if we look at that, that's K times the A over W that we had originally. And so if we look to combine this together, we're going to get A over 600W. Now, we can plug in from here. We want to know how many bags, so we're looking for N. The A is the area that we need to cover, 9,000 square feet. And again, we're still just using 3-pound bags. And so that's gives us 5 bags needed for the 9,000 square feet of yard.